is Brent, and I'm an applied engineer here at Deepgram. Today I'm going to talk about the pros and cons of our on-premises deployment option, as well as do a walkthrough of deploying Deepgram services on your own on-prem environment. First off, why would you opt for an on-prem deployment? Using Deepgram as a service has a variety of benefits. First of all, it's extremely fast to start developing with. From signing up to getting an API key to getting your first request and response can take as little as a minute. Yes, 60 seconds to get best-in-class language AI out of the box. Using Deepgram as a service also enables you to avoid all hardware, installation, configuration, backup, and maintenance-related costs. With that being said, there are situations where an on-prem deployment might make sense. The most common use cases we have seen are when you have higher than normal security and performance requirements. If your industry doesn't allow for sending any data to a third-party provider, or you need ultra-low latency with ASR co-located with your other services, on-prem can meet these requirements. With that said, let's walk through a deployment. I'll spin up a cloud server instance, configure it with container management software, download and deploy Deepgram assets, and test our setup. This video will feature AWS, Ubuntu, and Docker, but you can find additional resources for other cloud providers, Red Hat Enterprise Linux, and Podman in our developer documentation. There is one big prerequisite to this whole project: getting in contact with the Deepgram account executive. They will get to know the details of your use case, make suggestions, and provide you with permissions and asset links needed for the deployment process. Throughout this video, I'll include embedded links for each web page I visit, and you can also find a text guide for this whole process linked in the description, which includes many of the commands I'll be using in the terminal. Let's get started then. First, we'll set up our EC2 instance. I'm already logged into the AWS console, and I've generated a key pair and have it configured with SSH on my local machine. If you need help with that process, I've linked the relevant documentation. To create our instance, we're going to the EC2 dashboard, and then we'll quickly verify that we have our desired region. Then we will launch instance. We'll name our instance. Here, I'm going to name it Deepgram Server. And then select our OS image, which for this video is going to be Ubuntu 22.04. The official docs will have the most up-to-date list of recommended Amazon machine images and other Linux distributions, and you can choose from any of those. We're going to verify that we have the 64-bit base 86 architecture as well. Then we are going to choose our instance type. Deepgram highly recommends running our products on GPUs, and we're going to choose the G4DN.2X large instance type to give us the needed specs for our deployment to be performant. Hardware specifications are also available in our documentation. For our login key pair, we're going to choose a key pair. I'm going to choose the one that I already referenced earlier and generated. For our network settings, we're going to create a security group. We're going to allow SSH traffic to allow us to manage the machine, and we're going to allow HTTPS traffic as well if you need to allow requests to your service. For this video, we're not going to be setting that up, so I'm not going to initially select that. If you are co-locating your on-prem deployment with other services, you may have a more detailed network security configuration that includes denying HTTPS traffic from the internet or other various network configurations. Finally, we are going to increase our root volume to 48 gigabytes of storage. This is going to be persistent storage that outlives the instance, but you may have to have extra configuration settings if you terminate the instance to allow this storage to not be deleted as well. We'll double check if all the details are right in the summary pane, which initially looks correct, and then we're going to launch the instance. Once it launches, as you can see, it's fairly quick. The T4 GPUs that we used are very readily available on most cloud providers, and you could see that the launch was fairly quick. We're going to grab the public hostname for our instance so that we can SSH into the machine and manage it. One place to quickly find that information is the SSH client tab. So I'm going to click into the instance, going to select it, and then I am going to go to the Connect tab, and here I'm going to the SSH Client tab, which contains some supplementary information on how to connect to your new EC2 instance. So I'm going to take this host name and copy it to my clipboard and export it for future use. And now I'm going to log in. It's going to ask if we trust on only the first login. I'm going to say yes. And we can see that I've connected successfully to my instance. Once we're logged in, we're going to update the package list as well as upgrade any packages. Having an up-to-date system is important for security and other considerations. We are also going to install some GNU toolchain components, GCC, make, and wget, that are needed for building drivers and other components we will install. This process might take a second, so I'm just going to step away here for a moment. And we're back. So I've upgraded all of my system packages, and as you can see here, I've also installed the GNU toolchain components that I mentioned earlier. So now we need to set up the NVIDIA drivers and Docker in order to launch our Deepgram services. We first need to blacklist the open source Nouveau drivers that come packaged with our AMI. So to do that, we are going to create a blacklist file and paste in some lines. Like I mentioned before, all of these lines and commands I'm running are in our documentation. And we are going to regenerate our kernel with those drivers blacklisted. And then we are going to reboot the machine. So we'll be back in a moment here. So I've rebooted the machine and SSH back in, and now if I grep for those drivers, you can see that there's no output, meaning that the drivers haven't been loaded. And we can now install the NVIDIA proprietary drivers. So the NVIDIA drivers have to be downloaded from their website. So I've got that link pulled up here. And when searching for drivers, we want to make sure we are selecting the data center / Tesla. That is the GPU, the Tesla T4 GPU is what's available with the AWS instance type that we selected, although your exact driver details may differ if you aren't using AWS. Selecting that will auto-populate some other fields, and so we need to verify the operating system. Here I'm on Ubuntu, so Linux 64-bit, and my CUDA toolkit, I'm going to select the most up-to-date, and then I'll search. We are going to click download, and then on this screen we're not going to click agree to download. We're going to copy this link and go back over to our terminal, and we're going to download that file to this machine. And we can see that we have downloaded this NVIDIA driver file. We can see it doesn't have executable permissions, so we're going to need to change the permissions on this file so that we can execute it directly. And then we are going to run this file in order to install it. If you are on Red Hat Enterprise Linux or another distribution, sometimes there's custom installation instructions and you won't be able to directly run this file. But if you downloaded a .run file, we can directly install it. And this is going to take a moment, so I'm also going to take a step away here. We can see here that our NVIDIA drivers have installed. There may be warnings about the X library path or Vulkan components. You can safely ignore those warnings for our use case. As a note, if you ever terminate your cloud instance and then restart it, your cloud provider may change the underlying hardware of your instance, and you might need to reinstall the NVIDIA drivers. Now that that's complete, we can run NVIDIA SMI, which is a command that will check what GPUs are available. We see the Tesla T4 GPU is exposed and available for use, which is the GPU associated with the AWS instance type that we selected. Now we're going to set up Docker. We will follow the official installation page for this process. So first, we need to verify that some packages are installed properly. Then we are going to add their GPG key. line by line because the copy command doesn't work properly. And then we're going to use the following command to set up the repository. So now that that's up, we can update our package lists. Excellent. And we can install using each of the recommended packages that they have. And those are installed. So we can now run sudo docker run hello world, which is hello world to just verify that it's working properly. And it says, hello from Docker. This message showed that your installation appears to be working correctly, which is excellent. These instructions should also give us Docker Compose built in, which is a tool to help us start and stop related groups of containers, such as the API, engine, and license proxy Deepgram containers, which are always run next to each other. We can check if it is installed by checking the version, Docker Compose version, and we see here that version 2 is installed. If for some reason it isn't available on your system, you can follow the Docker documentation to install that independently. You'll notice that we ran the docker run command with sudo. We want to give our default user permissions to run Docker commands without sudo, and Docker also provides instructions on how to do that. So over here, we are going to create the Docker group. It may already exist. Sometimes it is automatically created with the Docker installation. And we're going to add ourselves to the Docker group. And then we're going to run the following command to activate the changes. And now we can run docker run hello world without sudo, and we see that that works correctly without any permissions issues. The Deepgram engine image uses the NVIDIA runtime to interact with the GPU on your machine. To make this available for your machine, we need to follow the NVIDIA Container Toolkit installation for Docker. Similar to the Docker installation, we are going to set up a GPG key. So I have this page up. We're going to install their repository and GPG key as displayed here. And then we are going to update our package list and install our package. Oh, accidentally had shift there. Update our package list. And you'll see here that we now have the NVIDIA repo available. And then we are going to install our package list. And it's installed. It may have extra output for your setup depending on what packages come default for you. And then there's some post configuration we need to do. We need to configure the Docker daemon to recognize the container runtime. And they say it's recommended that you restart it. So we're going to restart the Docker daemon. That's been restarted. And we can test by running a based CUDA container. You'll notice here the command, it's just running a Docker run container with the NVIDIA runtime as a CUDA container, and it's running that same NVIDIA SMI command that we ran earlier. It's going to pull that base image. And it runs. And we see the Tesla T4 is also available now to our Docker containers. This output looks as expected, so we can proceed. Now we are going to step through Deepgram's new self-service licensing and credentials workflow. Self-service on-premises gives you the ability to self-manage your on-prem API keys and container image distribution credentials. Previously, on-prem customers had to go through Deepgram to have on-prem API keys and distribution credentials made. Now, on-prem customers can create API keys and distribution credentials through the Deepgram API or directly through the Deepgram console. This feature offers flexibility and control over your Deepgram on-prem deployment using Quay and Docker. For example, you now have the flexibility to rotate and expire your on-prem keys and credentials according to your access control policies. This will all be done within Deepgram console. So I'm going to switch over the Deepgram console. I'm going to verify that I've accessed the on-prem products with this on-prem tab here on the left. And we're going to start by generating an on-prem API key. So I'm going to switch to the API key tab. And I'm going to create it, set my permissions for my on-prem demo key. And you can tailor these settings to your use case. I'm going to create the key. It's going to give me a secret that I'm going to copy down. And now I can see in this main menu that this key has access to the API and the engine products, which is what we'll be running today. So I'm going to export this for future use. And now I've exported that as an environment variable to my remote machine. To pull down Docker images for these products, we need container image distribution credentials. For this, we're going to go to the on-prem tab on the left. We're going to click Create New Distribution Credentials. And it's going to give me a Quay username, a secret, and then a shell command to log in that automatically has the username populated. So I'm going to copy the secret and the shell command. And we can also see by clicking here that this has access to the API and engine products as well. So I'm going to switch over and log in, and it's asking for my password, and I'll use the secret that was supplied. And you can see the login has succeeded. So now we can pull Deepgram images from Quay. So first we are going to identify the most up-to-date release on the Deepgram changelog page. So we're going to go to the changelog and filter by on-prem. And you can see as of the release of this video, the most up-to-date release is the July release. We're going to look at these tags specifically, and we're going to use the release 230705 tag. Note that the quay.io domain might not be at the beginning of these image names, but you're going to want to make sure it's present when pulling those images. So you can see this command, I docker pull quay.io with the proper release tag for both the on-prem API and the on-prem engine. And I'm going to let this run, and the engine image in particular is going to be several gigabytes. That's going to take a moment. So we're going to step back and I'll be back with you. That download has finished. So next we'll download the encrypted models from Deepgram. Your account executive will provide custom links for models that have been encrypted for use in your request. Place these in a models directory in your home directory or another one of your choosing. Just keep a note of the file path as we'll need it later. I've already downloaded these files to my remote machine. You can see I have the base and the Nova model available to me right now. So now we can download the configuration files for these images. Your Deepgram account executive will provide you with private links with customized configurations. I've already downloaded some to my remote machine. For this video, we'll use a default configuration file. As of recent releases, there is one main file, a Docker Compose file. This Docker Compose file is a YAML file that makes it possible to start and manage all of your needed containers in a simple command. This file can also be checked into source control to track the history of your Docker deployment, as opposed to passing everything as command line arguments to Docker. So if I look in this file, we have two services exposed here. We have the API service and the engine service, which have volumes mounted. As you can see, I took that model path in my home directory, and I'm mounting it to the engine so that the engine has access to the models to run inference on. We also need to have our API key passed to the environment. So I exported it earlier, and Docker is going to pull in that exported environment variable and expose it to the container as well. And that way the engine and API can verify that they are licensed properly. The API and engine images are configured with TOML files that contain various networking and runtime settings. A default version of these files with sane defaults are bundled with the Docker images, and you can use those. For this specific demo, I have mounted custom configurations as volumes. Here you can see in the config path the engine.toml, and then a volume mount for the API.toml file as well. If you would like to use custom configuration files, for example, to have more granular control over various settings, your Deepgram account executive can give you links to sample configuration files that you can customize and mount as I've done so here. As a note, you may also be provided with a license proxy configuration, which provides a more reliable connection to Deepgram's license servers to ensure maximal uptime. Again, ask your Deepgram account executive for more details on this. We can now start our containers with Docker Compose, running the up command. Note that in version 2, Docker Compose is a plugin to the Docker tool and not a standalone binary, so there's a space between Docker and Compose. If you're using version 1, there will be a dash. So I'm going to run this command. It's going to create my containers for me. And if I run the process status command, I can see that they're up and running. If we wait a moment, we can take these container IDs and we can use Docker logs to inspect some of the logs with the container ID to see that everything appears healthy. And we're seeing some info, and this is the key of what we're looking for. We're listening now. The API is listening properly. And at startup, you're going to see this message that it can't get any models. That's because the models are being loaded initially, but after a few moments, it will be available and those models will be available. And we can check that by sending a curl request to port 8080 against -version1-models. And we can see the output. I'm going to format this a little bit easier so we can all read it. JQ is not installed, so I'm going to install JQ to format this a little bit easier for us. And then I'm going to run that same command. And we can see that we have two models available to us. We have the Nova model and we have the general model, which is exactly what I had in my models directory. So we can see that those are loaded properly. This also includes available languages and other metadata for debugging. So we can choose one of these models and make a test request. I'm going to download some sample audio from the Deepgram website. In this case, a clip from the movie Ferris Bueller's Day Off. And we can see that that's downloaded as Bueller.wave. And then I'm going to send this to the local impeller instance and pipe the output to JQ so that I can read it a little bit easier, similar to what we did before. Oh, we can see that it's telling us to use the general model, as that's what's available. And we can see our response. Our transcript, yep, I said it before and I'll say it again, life moves pretty fast. Our local instance is up and running as expected. You now have world-class ASR deployed on your own machines. Congrats. There are a few other post-installation steps you may be interested in that are described in the official Deepgram documentation. Like I mentioned before, you may want to deploy a license proxy in your environment to ensure maximal uptime. There are also instructions for deploying with Kubernetes as an alternative to Docker, and Podman if you are using Red Hat Enterprise Linux. If you have any other questions, you can use the search feature on our documentation or reach out for further assistance. Thanks for watching.